But yesterday, we have this was the last thing that I did not do in the first section, and then we're going to do the finite and infinite sums here in a second. But this is the same type of question that you guys had with arithmetic, where they gave you two terms and you have to find a specific term, but it wasn't like the first one. So we were able to take the two terms that they gave us, write them as ordered pairs, and find the slope, because with an arithmetic function, your common difference is the same as your slope because it's a linear function. Geometric, guys, is what kind of a function? We said that yesterday. Exponential. Good. So in this case, they told me that the fourth term, so a sub 4, is 125, right? And they told me that the 10th term is 125 over 64. You can still write this as an ordered pair. This ordered pair would be 4, 125. And this one would be 10, 125 over 64. But can you find the slope between these two? No, because it's not a linear function. An exponential function, from one point to the next, the change is different. So you can't line this up like we did before and just find the common difference. So this is a two-step problem. It takes a little bit of time, but what you want to do, write this down. Everything you'll definitely have a question like this on your test. You're going to do the same thing every time. The only thing that happens is the numbers change. But you're going to find R first. Okay? The two things you need in order to write the rule. So we're going to write the rule, and then we're going to find, what did they ask for, the 14th term? We're going to find R first. The two things you need are the first term and the R value. So we're going to find R first. They do tell us, though, something very important right here. It says, assume that the terms of all the terms in the sequence are positive. What does that mean about my R value? It's going to be positive. If they alternate, positive, negative, then you know your R value is what? Negative. Good. All right, so we're going to find R first. We're going to do the same thing we did yesterday. I'm going to take the two terms. You use the one that's further away. A sub 10 equals A sub 4 times R to the n minus 1. That's our geometric rule. You always, on the left side of the equal sign, you always put the term that's furthest away from the first one. So let's fill in what we know. What is the 10th term? 125 over 64, right? Can you guys see that in yellow? Okay. Then what else do we know? What's the fourth term? 125. Do we know the R value? No, that's what we're trying to find. Do we know? No, we're not. We can't find the 14th term yet. Can we figure out how far away these two spots are from each other? Okay, I'm going to plug this in here. I'm going to say 10 minus 4. Your exponent, when you're trying to find the R, is the spaces between the terms. Spaces between the terms.
So it's not going to be 1.
It's not going to be 1. It's always going to be, when you're finding the R, it's going to be the spaces between. So how far is it from 10 to the fourth term? How many spaces? 6, okay? Every single time, you guys are going to do the same exact thing. So how do we solve for this? We're going to divide by what? 125. Okay, if I divide by 125, guys, if I divide both sides, do you agree with me it's the same as multiplying by 1 over 25? Since this is a fraction, if you have 125 divided by 64 divided by 125, it's the same as multiplying by 1 over 125. So what happens to my 125s? They cancel. So you have 1 over 64 equals R to the 6th. Now, instead of taking the square root, we're going to take the what? The 6th root. Some of your calculators do this, some of them don't. But guys, just think for a second. What number times itself 6 times is going to give you 1? 1. What number times itself 6 times is going to give you 64? 2. So what's your common ratio? 1/2. All right. Every single time you're going to do the same thing when you have a question like this. When it's geometric and they give you a term here and a term here, you first find the R value. How you do that? You put the term that's further away from 0 or from 1, however you want to look at it, on the left-hand side of the equal sign. And then your exponent is the spaces away those two are from each other. So now that we've found our r is 1/2, let's find out what the first term is. The question is, what's the 14th term? We're going to get to that in a second. But on the test, I think it asks you for the rule and then to find the term. So you're going to have to know how to do this. So we're going to do the exact same thing we just did. But we know the r value. You can use either term you want to. It doesn't matter. Do you guys want to use 125 or 125 over 64? 125. Okay, so what term is 125? The fourth. Okay, so we're going to say a sub 4 equals a sub 1 times r to the n minus 1. And again, the exponent is the spaces away. So the fourth term is 125, correct? Do we know the first term? No, we're trying to find it. What's the r value? 1/2. And how many spaces is the fourth term from the first term? 3 spaces. Right? 4 minus 1. When I cube 1/2, what do I get? 1 over 8, good. How do I get a sub 1? How do I get my first term? Multiply both sides by 8, okay. So what's 125 times 8? Everybody has a calculator, come on. 1,000, okay. So do I have enough information now to write my rule? Do I have my first term and do I have my ratio? Yes. So you can go ahead and write your rule and then find whatever term they're asking for. Your rule is a sub n equals the first term, which is 1,000, times r, which is what? 1/2 to the n minus 1. Now here is just where you guys are going to have to use your calculators because I think on the test it says no decimals. So when you do this, you're finding the 14th term. So I have 1,000 times 1/2 to the what power? 13th power. All right, if you just throw that in your calculator, some of you will get the fractional answer. Some of you will not. Go ahead and try. Plug it in and see what you guys get. The answer here, the 14th term is 125 over 1024, which is the same thing you got, but let me show you how.
I have this calculator. Can I just bring that?
Yeah, absolutely, sure. If you have this TI, if this one, you guys have this, if you hit the the alpha button, and then math next to it, a little fraction comes up. So like you can put in 1,000, then hit alpha, and the link button right next to it. You guys understand what I'm saying? Hit 1,000, arrow over, and then you hit alpha, and then the button next to it, and the fraction pops up. And then you can just plug it in, and it'll keep it in fractional form for you. Because on the test, it says no decimals. I don't think that one will. I think it keeps it in decimal. I could show you how to do it by hand, though. I got to look at that one, too. If you did it by hand, though, think about it. This would be 1,000 over, what's 2 to the 13th power? 8192? Okay. And then just simplify. What number is going to go into both of those? Okay, so if I divide by 2, I get 500 over 4,096. What number goes in it again? 2. So 250 over 2048. What number goes in it again? 2. Gives you 125 over 1024, which would be the right answer. So, I mean, if you don't have that TI-80 that does a fraction, it's not a big deal. You could definitely just keep it in fraction form on your calculator and just simplify. But every single time you have a geometric, the first thing you do is find the r. Then once you find the r, you find the first term, and then you can plug in whichever. But we'll practice these more. This is probably the hardest question that you guys are going to have. And it's just because it's awkward. But we'll practice it more. This, whoops. All right, let's go to our sums and geometrics, finite sums and sequences. My goodness. What does the word finite mean? That there's a set number. There's a beginning and an end. Infinite means what? It continues forever, okay? You guys are going to need to know the formulas. I'm going to provide you the formulas at the top of the test, but I'm not telling you which one is which. So you guys need to know that this is the finite formula and that the other one is the infinite. I'm going to show you exactly how to plug it in. It is not bad, I promise. But you need to know the difference. How can I look at this problem and know that this is a finite? What's the beginning they want me to plug in? 1. What's the ending they want me to plug in? 12. All right? If it was infinite, it would have an infinity sign. Or if it's a list of numbers, it'll be ... I'll show you. So this is what the formula looks like. What is a sub 1? What does that mean? The first term, okay? What is the R value? What's the R value? The common ratio. What's being multiplied every time? We'll just say common ratio. And then what is the N value here? How many? The number of terms. Now, I'm going to tell you guys something, and it's like a little way to cheat the system. Because not always will they start with 1 and end with a number. Or not always will you be able to count how many numbers there are. So a little trick to find out how many number of terms there are, we say top minus bottom plus 1. And I'll show you what I mean by that in a second. But when they ask you for the N value, for either geometric or arithmetic, it's top minus bottom plus 1. I'll show you what I mean in 1 second. Now, this is very simple because you guys are going to have the formula. The thing that's hard is actually plugging it into your calculator. So let's think about the things we need. I know this is a finite because it has a beginning and an end. So the 3 things I need are the first term, I need the common ratio, and I need to know how many terms I have. Let's start off with the number of terms. Top minus bottom plus 1. 12 minus 1 plus 1. How many terms am I talking about total? 12. Okay, that's what you're going to plug in for your N value. What is my R? What's my common ratio that I'm multiplying by every time?
Why did you add the 1 back?
I'll show you why in a second. When it starts with 1 and ends with a number, it's always the same thing. But like you'll see. If it was like start with 7 and end with 235, how many numbers is that? You'd have to say top minus bottom, and then you add 1, so it includes both of them. What's the common ratio here? What's in the parentheses, guys? Okay, so your common ratio is 0.3. And how would you find the first term? Say it again. Okay, well, how? But why are you multiplying those two together? How would you find the first term? You plug in 1. Why am I plugging in 1? What does it tell me to start with? 1. If they told me to start with 7, what number would I plug in for N? To find the first term? 7. There you go. The bottom number is where you start. So you would say 4 times 0.3. So your first term is 4 times 0.3 is what? I don't need to write it out. What is it? One more time? Okay, that's what I thought. That's what I thought I heard. Just making sure. All right, so we figured all that stuff out just kind of by looking. Now you're going to put this into this formula. It's awkward, guys. It's very awkward, but you can do it, I promise. What is the first term? You guys just found it for me. 1.2. Okay, that goes out in front. Now I'm going to have a fraction. I have 1 minus, what is the common ratio? 0.3. And I'm going to raise it to what power? To the 12th power, good. Over 1 minus the common ratio, which is 0.3. All right, half the battle is just, God bless you, identifying everything and plugging it in. Now you have to use your calculator. Where do we begin? Some of you can plug all of this in with all of the parentheses in the right spot and get the right answer. I don't suggest doing that. We start with the exponent. I'm going to say 1.2 times 1 minus, what is 0.3 to the 12th power? Okay, say it one more time. 2, 3, 4, 5, 6. 531. And then what's 1 minus 0.3? 0.07, okay. Yeah. Some of you got this, right? 5.3144, like that, times 10, or e to the negative 7. That just means you move the decimal place 7 places that way. Put six zeros in front of it. So now we're just going to use our calculators. It's not great, guys. I understand that. But 1 minus, and then put in 0.123456531. 531. What do you guys get? 0.99999, like this. All right. Okay. We can abbreviate it, and then divide it by what? 0.7. So now we have 1.2 times 0.9999. Just give it a couple nines, and then hit enter. Divided by 0.7. You get about 1.714. 1.7-ish. You didn't?
I got 1.4.
Did you do?
No, 1.7.
Okay, you have to do 1.2 times the 0.9999 and hit enter. Then divide. If not, it's going to divide the 0.999 first.
I'll put all of it in, like the first thing.
Uh-huh. Okay. Freddie put all of it in his calculator and got the exact same thing. If you can do that in your calculator, guys, you're going to help yourself out. That's why it's so important to have your calculators with you and to practice. If you have the same calculator as Freddie, say, hey, can you show me how you did it? I have the same one if you guys want to ask me. If you don't have if you only have a scientific, that's fine. You'll still get the same answer. You just have to put more legwork into it. But you'll get the same answer. These problems generally work out to be ugly, but it's not because you guys don't know the formula. It's not because you don't know what goes where. It's just because manually putting it in is a little difficult. So we can practice with this more today, more tomorrow, more on Monday. All right, but let's just go through the workings of this. Find the sum. Is this geometric or is this arithmetic? How can you tell just by looking? Why is it geometric though? You're right. Because the variable's in the exponent. Perfect. Okay. So I know this is geometric. Is this finite or is it infinite?
Finite.
How is it finite? How do you know? Because there's a starting point and a stopping point. Okay. So that's how you would determine which formula to use. So now let's talk about it. What do I know? Or what do I need to know? I need to know the first term. I need to know the common ratio. And I need to know the number of numbers. This is where top minus bottom plus 1 comes in handy. How do I figure out the number of numbers? 16 minus 3 plus 1. What's 16 minus 3? 13 plus 1 is 14. So my n value is 14. That accounts for both the 3 and the 16. If you just say 16 minus 3, you're not accounting for both of those. So what is my r value? What am I multiplying by every single time? Negative 1/2, perfect. And then how do I find the first term? Plug in what? What do I start plugging in? 3. Whatever that bottom is, it tells you, hey, start with this. This is the first term. So in your calculators, or write it down, you have 5 times negative 1/2 to the 3 minus 1, which is 2. Go ahead. Tell me what you get. 5/4?
5 over 4.
5/4? Okay. So if you want to keep it as a fraction, perfect. If you change that to a decimal, is that a terminating decimal? 1.25? Depending upon what the test says is how you need to keep it. If it says no decimals, then keep it as a fraction. If it doesn't say, then decimals are fine. So now we just plug this into the formula. What is the formula? I need my first term, which is 5/4 times 1 minus, what's my common ratio? Negative 1/2 to the what power? 14th power over 1 minus what? Negative 1/2. If you guys can get that far right now, that's great. Now with our calculators, if this is a little difficult to maneuver, that's all right as well. If you can put all of it in at the same time and get the right answer, amazing. If not, that's okay. We'll go hand by hand or step by step. Will your calculators give you guys a value for negative 1/2 to the 14th power? Teeny tiny, right? Some of you are probably getting 6.1035 times e to the negative 5. That means move the decimal point over 5 times. So what'd you get, babe?
I got 0.000040 zeros and then 6.035.
6-1. We'll just go 61035. Okay, I'll do it all. Freddie, did you put it all in? You got an answer? Okay, what'd you get? Okay, all right, let's see what we get at the end here. On the bottom, 1 minus a negative 1/2. 1.5? Or 3/2? Agreed? Okay. So now we're going to keep going. 5/4. What's 1 minus that 0.00, whatever? Just give me 4 or 5 decimal places. 0.99. And then what? Okay. Divided by 1.5 or 3.2, 3/2, whichever. So now what's 0.994 divided by 1.5? What'd you guys get? 0.66, 266, all that. All right, now times that by 5/4 or 1.25. And you get 0.82833. Freddie, is that what you got? Yep. So if you know how to use your calculator and you know how to plug in using parentheses and stuff, you could do all of this in one step. What I need to see is this. I need to see how you got to that. How you found the first term. How you found what the formula should look like and what you put in your calculator. Then from there, it's either you guys figuring out how to use your calculator if it doesn't do it all for you, and we can work on that.
If it's not working during the test, are you allowed to?
No, we have until Wednesday for you to ask me questions about that, not the day of the test. No. All right, last thing I want to go over. This is real simple. This is an infinite. How do you, again, you guys are getting these formulas. It'll be at the top. It'll be printed at the top of the test. You just have to know the difference. How can you tell that, oh, wait, this is the infinite one? It has infinity up here, all right? They're always going to tell you what to start with to find the first term, but there's the infinity sign at the top. This formula is much easier. What are the only 2 things you need? The first term and the common ratio. You don't need to do all the fractions and all that stuff. This is a very basic formula. So let's go over these 2 problems, or 3, and then we're done. Okay, I know this is infinite. Why do I know this is infinite? The infinity's at the top. So what are the 2 things I need? I need the first term, and I need the common ratio. What is the common ratio, just by looking at this?
0.6.
Okay, 0.6. And how do I find the first term? Plug in what number? 0. If it said n equals 7, we'd plug in 7. So if I put a 0 right here, guys, what's 0.6 to the 0 power? 1, and 1 times 4 is So now I'm going to take that information and I'm going to plug it into the formula. What is the formula? What do I put in the numerator? 4 over what? 1 minus 0.6. So what's 1 minus 0.6? So it's 4 over 0.4. Do that in your calculator. What's 4 divided by 0.4? There you go. Looking at this one, guys, how do I know that B is infinite? How do you know it keeps going? Because of the dots. The 3 dots say, and so on, and so forth. So I need to identify the major important things is the first term and the ratio. Well, what's the first term? 3, because you can see it. How do you figure out the ratio? What did we do yesterday? If it didn't just jump out at you, how'd you find the ratio? Take one term and divide it by what? The one in front of it. So I'm going to take 0.03 and divide it by 0.3. What's 0.03 divided by 0.3? What'd you guys get? So 0.1, okay. So let's plug this in the formula. What goes in the numerator? 3 divided by what? 1 minus 0.1. So what is 1 minus 0.1? Okay, so 3 divided by 0.9. Do that in your calculator. What's 3 divided by 0.9? 3.33. Repeating. There you go. All right, let's look at the last one. Infinite or finite? How do you know it's infinite? Because it's the infinity at the top. So there's only 2 things we need. The first term and the common ratio. What's the common ratio, guys? 1/3, good. And how do you find the first term? You plug in what? Start with 1. Why am I starting with 1? Because it tells you to start with 1. So if I put 1 here, 1 times 1 minus 1 is 0. So 1/3 to the 0 power is 1. So 1 times 6 is 6. So throw it in the formula. What goes in the numerator? 6 over 1 minus 1/3. So you have 6 divided by 2/3. Okay. You could do that in your calculator. Or you could say 6 times what? 3 over 2. 6 times 3 is, divided by 2 is, there you go. If you did that in your calculator, you hit 6 divided by, you could put 2/3 in a parenthesis, or you could make it a fraction. You get the same answer. So really, truly, the hardest part about these ones is just the entering into the calculator, which I understand is difficult. That's why we're going to practice a bunch. But as far as the test next Wednesday is concerned, we've covered all of the material. So come tomorrow with a calculator that you're going to use, and let's practice. I'll answer questions, whatever you need, but we've got to practice. Very important.